Okay, we're going to do a little review today. I want you to solve this quadratic equation. And I want you to, when they say solve, they want you to find the zeros. And we found out that finding the zeros means the place on the x-axis where the parabola crosses, okay? So there's several things that you found out already. The first one is that to solve this, we need to find out what our ABCs are, not the T's. The T's are just like X's in this. And if it helps you, change them to X's. I'm going to leave them T's. And you will need to find your values of A, values of B, and values of C in order to solve for the zeros, okay, or the x-intercepts in this case. However, the first rule before you solve using any kind of method, there are several methods, the first rule is that your quadratic has to be in order from descending exponents, the largest one first, the next one, and the next one, down to the constant, okay? And more importantly, your equation has to be equal to 0. So if we look here, at both sides, neither side of this is 0. Now you can change either side to as long as one of the sides is 0. The easiest one seems to be just get rid of this, right? And make this 0. So since we have a negative or a minus 3t, we're going to add 3t to make it go away. Now some of you got kind of confused yesterday about where to put this 3t over here, because we know it's not a t squared, and we know it's not a t, so it's going to need a little place of its own. Now, the best thing to do is go ahead and decide where it belongs. If we have a t squared here and the constant here, it looks like the 3t needs to go in the middle, right? So underneath here, we're just going to go 3t. Now, this isn't essential. You don't have to do that. But if you don't choose to give it its own column, you're tempted, if you put it here, to add 2 and 3 and get 5t. And that's wrong because this is not a t. You can't add t's to a constant. Do y'all see? And that's why I encourage you to make the column of its own. Yes? And so now we have t squared plus 3t plus 2 equals 0. So we've taken care of our first qualification in order to solve this. Your quadratic, this is quadratic because the highest exponent is 2. It's in standard form where it's descending exponents. It's equal to 0. So now we can find our ABCs. Now remember, the A is the coefficient in front of the t squared. So what is A equal to? 1. There's an invisible 1, so A is 1. And if you want to remind yourself for a while, put the sign so you don't forget the negatives when they show up. Okay, so what is the B?
3.
3, 4.
Yes, it's the coefficient in front of the t. And so it's a positive 3. And one more time, the C stands for the constant. It's 0.
+2.
Positive 2. So here are our values that we're going to use. Now, there are several ways that you can solve a quadratic. You can solve a quadratic by graphing it. You can solve a quadratic by factoring. We chose to learn the quadratic formula because all you need is one way to solve it for your GED test, and the quadratic formula will solve it no matter what. Factoring won't always work, okay? But quadratic formula will always work to solve for this, to find the zeros. And so if we remember, the quadratic formula is x equals, or in this case it will be t, x equals negative b plus or minus the square root of b squared, put your b in parentheses, minus 4 times a times c, come back all the way to the equal sign, not under the x, 2a. So here's the formula we're going to go by in order to solve this and find out what the zeros are, or the x-intercepts. So I like to start down here because I like the shortcut of working up. So we have x equals. Now remember, this is a hard place for some people, okay? This first b. You need to put the negative in first, then the value of a b, which happens to be a positive 3. If it was a negative 3, you would need to put another negative that goes with the 3. Y'all understand? Okay. And then the next thing in the equation is a plus or minus, and then we have the long square root radical. So in parentheses, we put the value of b again, 3 squared, minus, there's a 4 in the equation, a is 1, and c is 2. And don't forget the all over 2 times whatever a is. In this case, it's 1. Okay? So now from here, the thing that looks the most complicated is this radical stuff. So let's start there. 3 squared is 9. And you write the minus. Then just multiply these. Since you've already used this, it's not a negative 4 anymore. You've already used the minus. So just 4 times 1 times 2 makes 8. We have not found the square root yet, so we still have to find it. Underneath the radical, 9 minus 8 is 1. We have not found the square root yet. And now, either in your head or your calculator, find the square root of 1, which is 1. So the answer to all of this stuff is 1. We're going to make this a lot easier because this is conglomerated now. So let's just write it again so it looks a little better. I'm going to come over here. So now I have x equals, and I'm just going to copy here. I have a negative 3 plus or minus negative 3 plus or minus, now I have a 1 divided by 2 times 1 is 2. Much cleaner because we took care of this mess. Okay? Now, when we see the plus or minus, we know that there are 2 answers. And so we're going to split this up now. And usually I split it out to the side. I think we better do it underneath to make sure everybody can see. So the first one is that x equals the negative 3 plus the 1 over 2. And the other one will be x equals the negative 3, because it's right there, minus 1 over 2. And all we have to do from here is just actually do your addition, subtraction, blah, blah, blah. So x equals negative 2 over 2, which equals 1. So one of the zeros is 1. Let's do this one. X equals negative 4 over 2, which equals a negative 2. So the place on the graph, let's make us a little graph over here. Okay. So this is the x, and this is the y, and what we found were x's, right? Even though this said t, they're the same as x's, okay? We found our x's, our zeros. And so one of them is at 1. Remember, they're on the x-axis. And the other one is negative 2. Now, another thing that we found out is if the leading coefficient is positive, then your parabola is going to point up. If your leading coefficient is negative, it will point down. Everybody fine with that? Okay, and so we know it's going to point down, up. No, the arms are going to go up, right? But you know, we figured out another thing the other day. So let's move on a little bit. We also know by looking at our ABCs, we can figure out what the vertex is, right? About the vertex? Okay, do you remember how to find the x of the vertex? The x of the vertex has a little bitty equation. Vertex is going to be a point. We're going to have an x and we're going to have a y value, okay? So we found out that the x of the vertex is going to be equal to negative whatever b is over 2a. Okay? Remember that because that one is not on your formula chart. So to find the x of the vertex, it'll be negative b over 2a. So let's find x equals negative because it's in the formula. Now let's find out what b is. 3 over 2 times whatever a is. 2 times 1 is 2. Yes? So the x of the vertex is negative 3/2. So far, so good? This is a memorize, guys. Memorize it. Dream about it. Okay? Now, to find the other part, the y part, we simply put in the negative 3/2 in every place that there's an x or t or whatever. Because this we can consider y for right now. Okay, so we have x squared. Let's put x is a negative 3/2 squared plus 3. I was going to put 3 over 1. Let's just do 3 right now. Whatever x is, or t, or whatever, negative 3/2 plus 2 equals y. So we're going to square this. Remember, anything squared is going to come out positive. So we have 9/4 plus, because 3 times 3 is 9, 2 times 2 is 4, 9/4 plus, and remember, if you're going to multiply fractions, you can multiply the tops, negative 9/2 plus 2 equals y. Now you can either find common denominators or you can use your calculator here. You're going to have negative 9/4 if you do this part on the calculator, plus 2 equals y. And then again, common denominators. So you're going to have negative 1/4 equals y. So our y value is negative 1/4. Okay? We found the vertex. So now we know where this comes down. We've got to go to negative 3/2. That's 1.5. You can change that to a decimal in your calculator. It'll be easier to know where to go here. So negative 3/2 is the same as negative 1.5. Here's negative 1, and here's halfway. and then negative 1/4, which is about right here. Wow, what are we doing here? This is interesting. Somewhere Deborah might have made a mistake because this is the turning point. I wonder if this was a negative, supposed to be a negative. Let's look here. I'll do the factoring real quick because I can tell it quicker this way. Yeah, somewhere I missed a negative. So the two roots, somewhere I missed a negative. So when you go back to the quadratic formula that you did, that you wrote down in your notes, it's supposed to be -2 and -1, okay? We'll look through your notes and I'll tell you where we made the mistake. But on your notes, please make that change where we said x equals -2 and x equals 1. I missed a negative. And so x actually equals a -1. And did you notice I knew I made a mistake because if this is the vertex, then that, y'all see? So see, math is full of learning by making mistakes. Practice, practice, practice. I'm old and I'm still making mistakes. So just be aware of how to figure out that you made a mistake. So now we know that the vertex is here, but through these two, there's one more thing that will make this graph even more accurate.
I got a negative or 1/4 on the 3/2.
You should have gotten a positive 9/4. Because, did you put parentheses in your calculator? Did you put the negative inside the parentheses? And you got a negative 9/4? You show me. Is anything squared? I mean, just this part? Let me see it. Oh, yeah, because you did the whole thing and got the negative 1/4. that we did. So good. I thought you were talking about what you just got here. Yes, you did the whole thing, and that is correct. That's what we got right here.
Okay.
Negative 1/4 for y.
Okay.
Good job. Good job. Okay, there's one more thing that we know how to do. I keep building here, and you guys know this. How do we find the y-intercept? I'd kind of like to know how wide this thing is, and I need to know where it went across the y. I'm just adding to you the things that you already know and show you how to use this. So let's find the y-intercept. So now we know what the vertex is. We know that the x-intercepts were the zeros, and that was -1, 0, and -2, 0. Okay, now I want you to find the y-intercept. And if you remember from other videos, there's only going to be one y-intercept. There can be 2 x-intercepts or 1 x-intercept or 0 x-intercepts, okay? But only one y-intercept. We know that the y-intercept has 0 in for x. So using the original again, we're going to put 0 in for x, or t in this matter. So I have 0 squared plus 3 times 0 plus 2 equals y. Which is awfully easy because 0 squared is 0. 3 times 0 is 0, so y is going to equal 2. So our x-intercept is pretty easy to find. You just put zeros in. So our y-intercept is at 1, 2, right here. So now we found out that this goes through here and up. This side will mirror that, so it's more like this. Y'all see how the more things, the more points that we find, the more accurate your parabola will be when you graph it. Okay, so we have found out how to find the vertex, how to find the x-intercepts, and how to find the y-intercepts so far. Next week, there's a couple of things more that you can learn about this. We're not going to add those to you today. I'm going to show you something. It's kind of like, I call it a secret code inside of the vertex form of a parabola. We talked yesterday about the vertex form of a parabola. You know what I want to do? I want to go back through the quadratic formula where I made that mistake. And let's find out where I made that mistake so you can correct your work in your notes. So I said x equals -3 plus or minus the square root of 3 squared minus 4 times a times c. You can follow along in your notes and I'll tell you when I find it. And 2 times whatever a is. Okay, so we worked to the top and we had 9 minus 8, still the square root. 9 minus 8 is 1, and the square root of that is 1. So far, so good. All of this came to 1. And so we said x equals -3 plus or minus 1 over 2, correct? So then we split it up and we said x equals -3 plus 1 over 2, and x equals -3 minus 1, there it is, over 2. So we continued out here and we had -2 over 2, and I think I made this, right here's where I made my mistake. Should have been a -1 right there. This other one was correct. So change your notes where it says this. -4 over 2 equals -2. This was where I made my mistake. Please change that in your notes. Oh, yeah. Please, please, do you see where it is in your notes? Please change that.
Okay, I got it.
And the way we figured out that there was a mistake was the graph looked really weird. So we knew something had to be wrong. So if you're in that position, just go back and check your work, okay? Okay, now that I feel better, let's go to the other part that I was going to show you that's new, but I kind of think you'll like it. Okay. Here's the example we're going to use. Let's see if I can find it. Okay. Okay. It says f of x equals 3/2 x plus 3 squared minus 6. Okay, this is in what we call the vertex form. The vertex form is y equals, or f of x, 3/2. Oh, I'm sorry. A x minus h squared plus k. This is the vertex form of a quadratic or of a parabola, okay? It's called the vertex form. Now, each of the things, when we very first started quadratics, I told you that the parent function was y equals x squared. And that's true. Y equals x squared begins at 0, 0. It's positive, moves up. That's the parent function. This is also the parent function in vertex form, and the reason for the addition is the additional stuff here tells you how your parabola is going to move from this position. So every one of you should have a little tiny parabola. Okay, we're not going to use it this very second, but probably in about 3 minutes. I left one on your table, and then you need just one of your graph paper. It doesn't even matter if it's one that you've used already. You just need one just to play with. Okay? So I'm going to tell you what each one of these pieces does. The A tells you how wide or skinny. How wide or how skinny the parabola is going to be. How wide or skinny. Now, the way that we tell is that if A equals 1, then it is the standard width, okay, of the parent function. If the coefficient in front of this parentheses is less than 1, then it's wider. If the value of A is greater than 1, then it's skinnier. Okay? That's what the A does. Almost. Okay? Do you want to move over?
Thinking about it.
Now, the sign that is in front of the leading coefficient, the sign right here, this is the sign. If it's positive, the arms go up. If it's negative, the arms go down. Okay? Everybody okay? We found out, because this is the vertex form, they call it that because H and K are the coordinates of the vertex. I don't know if I'm on the screen yet. Okay, H and K are the coordinates of the vertex, but we can also use this to see how this parabola moves around on the screen, okay, or on the graph, the coordinate graph. So this H, I don't know if this is confusing you or not, but the H, which is, you've got to remember that the number that's here will move, it will move the vertex of the parabola left or right. Left or right. That's the one that is inside the parentheses. Is it going to move left or right that many? And one more. The K out here will tell you how far the vertex moves up or down. Okay, that's what all this stuff means. Let's get that down because you'll want to refer to it or take a picture of it, whatever you want, but this is the key to reading a vertex form of a parabola.
So one of them moves up and down?
No, the K
Oh.
moves up or down, the H moves left or right. Now there's a lot of stuff there on the board, and I'm going to try to leave it and make sure I have enough room. The one thing I want to point out to you, and this is something you're going to have to remember, so I've got kind of a silly way for you to remember it. If we're going to move up or down, if this K says we're going to move up or down, then if it's positive, which way do you think it'll move? Up. And if it's a minus, it's going to move down that far. Okay, makes perfect sense. The number that is inside of the parentheses is a little bit wacky. Okay? Yes, that tells how far you're going to move left or right, but it's opposite. And the silly thing that I use for the parentheses is like he's locked in a room, and he's been locked in that room for a long time, and he's starting to go crazy inside the parentheses. So he's moving left or right, but he's crazy. And so he moves the opposite way of what it says. So if it's negative or minus, then he's going to move to the right. If it's positive, he's going to move to the left. All right, everybody okay? So now we're going to try to apply that to this equation right here. I'm going to leave that up for a little bit. Okay, so we're going to use it on this. Now, what we do, and I'll show you on here in a minute, but what we do is look through and see what all things are added to y equals x squared. Because y equals x squared is where the very first part is. So I have y equals x squared. So I'm already taking care of y equals x squared. Do you see it? So all the numbers that are left will make that original parabola that has the vertex at 0, it will make them move some way. Okay, so let's look at this, and then we'll look at it where you can use your own parabolas. Okay, so the first thing we're going to look at is this 3/2. Now 3/2 is the same as 1.5. So is it larger than 1? Is it smaller than 1?
Larger.
It's larger because it's 1 and then a half.
Oh.
1.5. Okay, so it's larger. If it's larger than 1, this seems backwards too. If it's bigger than 1, it's going to be a skinnier. Okay, so the first thing we're going to write is we know it's going to be skinnier. It's going to be skinnier than the normal. Okay, so we've taken care of this piece. Now we have a +3, but he's trapped inside of the parentheses. So which way is this going to move?
Left to right.
Okay, which way though? It's crazy. left, because this looks like it would go in the right direction, but he's crazy. So we're going to move the vertex left 3 units. Okay, so we've taken care of that one. We have one more right here. So this one is outside of the building. How is he going to move?
It's gonna move to the right.
He's
Down.
down because he's outside. The outside one moves up and down, and he's normal. So we're going to go down 6 units. Now that I've figured out how this equation moves, then what I'm going to do is start. Now, when I first started moving parabolas in high school, I thought, but just focus on the vertex. We're moving the vertex, okay? So the vertex, where we start, is at the parent function. So our vertex was here in the beginning, but then this happened because of that. This happened. Let's leave the skinnier for a minute. Okay, the vertex moved left 1, 2, 3 units. So now it's not here. It's here. But then it moved down 6 units. 1, 2, 3, 4, 5, 6. So now the vertex of this parabola has moved. Okay? And the only thing you can do without making a T-chart is just to make your parabola look skinnier. So we'll make it a little bit skinnier. Or you could make it skinnier, okay? But it's skinnier. Do you guys see? So this is the parabola graph of this equation. Because you just start with the parent function, do all the moves that the extra numbers say, and that's where the parabola is graphed without doing a T-chart. Now, it's just a sketch, because what you really need to do is find the x-intercepts and find the vertex and all of that stuff. But guess what? The vertex is right here. And this was -3, -6, right? This is the H, and this is the K. There's the H, but he's crazy. And this is the K. Y'all see either way. Now let's do this. I know I demonstrated it, but now you can use your parabola to figure these things out. So here's your parabola. Oh, let's move this so everybody can see. So let's go right here. Okay. So the original parabola, the parent function is right here. Sort of, like right here. Okay. The parent function is right here. And then as we look at the things that's supposed to happen, we're going to move it left 3 units. So I just concentrate on this point, the vertex point. I'm going to move it 1, 2, 3. And then I have to move it down 6 units. 1, 2, 3, 4, 5, and 6. So this is where our parabola will be graphed now. Y'all see? So the vertex form of a quadratic holds a lot of secrets. Okay? So you have those written down. The only we will be practicing those next week, unless you want that paper today. Okay? I just wanted to make sure that you see what the vertex form is good for. Yeah? Do you think you could find the y-intercept out of there really easy?
And before on the board.
Oh, it looked like it?
No.
Let's just try it, because then we can find out exactly where it is. Okay, now the skinnier means that we would have made that skinnier, right?
Yes.
Okay. So the y-intercept remember, the y-intercept is a point where x equals 0. So plug 0 into this formula right here. So if you plug 0 in right here, 0 plus 3 is 3. 3 squared is 9. 9 times this, 9 over 1 times 3 halves, equals 27 halves, and minus 6. So y is going to equal 15 over 2?
Yes.
Yes. Okay, so the y-intercept is going to be on the y-axis at 15 over 2. Now, 15 over 2, if you change it, yes. If you change it in your calculator, it's going to be 7.5. Is that correct? Okay, that's the y-intercept. So here we were. We moved to the left 3 and down 6. So we're right here. Now you can tell how skinny I need to make this, because here's going to be the vertex, no question. And then, but it has to go through 7.5, which would be clear up here. So we're going to have to make it skinnier so it will actually go through there. And then you all are able to see how skinny or how wide it really is by using the y-intercept. Y'all see? It's a lot of information. I wanted you to have it down in your notes so we can play with it. Okay? We've got some transformation worksheets for next week. I just wanted you to have the notes today so we can move right into it. Today and tomorrow here in class, however, we're going to finish working on your quadratic worksheets, ask questions, and if you're ready for the transformation worksheets, I already have those. And I think what I might do for you remote students, I'm going to go ahead and email those to you so that you will have them ready when we work on them on Monday.
Okay.
Good?
Okay.
Do y'all have any questions on the worksheet so far, or do you just need to text me or call?
No, I've
I'll take you.
got it pretty down.
You're okay for right now?
Yeah.
Okay. That is it for me today.
Okay.
Okay. You know, I love y'all.
We love you too.
Bye.
Okay.
See you next week.
Yes. See you next week.
All righty. Bye-bye.
You have a blessed weekend.
Oh, you too. You too. Tomorrow's going to be chilly. Be careful.